Hello, welcome back. Today we're going to continue our discussion, but we're going to start with a new rule today. It's called the product rule. Now, before we get into what the product rule is, I want to take a moment and talk about something we call higher order derivatives. To do this, we're going to use physics. So let's imagine we have a distance time graph on hand here. And we have our graph right here, so there's our function. And this function right here represents our distance over time. At some point C, we know we can draw a tangent line to that graph, a line tangent to it. So it's something similar to this. We can find the slope of our tangent line. And from physics, this would be our change in distance over our change in time. You might recall this is what we call velocity. So the slope of our function at any given point would be the velocity of an object traveling. And we get that because we're looking at the change in distance over change in time. So that tells us something. It tells us that we know that the derivative of position is velocity. In other words, that the slope of position is our velocity. Likewise, if we want to find the change in our velocity, remember, if you forgot this little triangle, that's the Greek letter delta, and it means change in something. So the change in our velocity is going to be acceleration. Now we do have something called the change in acceleration. We talked about this before. That's called the jerk. And the jerk is what you experience like in a car. Like if you step on the gas, when you step on the gas and you're pushed back in your seat, that's the jerk. It's that sudden change in acceleration. So this will give us three formulas. The first formula is just position, S of t. In physics, that might be given like h of t equals like negative 16t squared. Remember, this is negative 1/2 gt squared. That's going to be our position graph. If we take the derivative or find the slope of our position, that's going to give us velocity. So the first derivative of position is what we call velocity. And we can see that from physics. V of t, if I take the derivative of this, we're going to get negative 32t. Remember, again, for velocity, it's just gt, negative gt from physics. If we take the second derivative of position with respect to time, we get the first derivative of velocity, which is what we call acceleration. So acceleration would just be the derivative, or negative 32, which is just negative g for acceleration. So the more derivatives we take, the more formulas we can create. For example, the third derivative, remember we talked about this, the third derivative of position is what we call the jerk. So let's explore how to take more than one derivative. Here we have the function f of x equals 2x cubed plus 7x squared minus 4x. And what we're asked to do is to find the second derivative. I know I'm looking for the second derivative because it's this f double prime. This says, find the second derivative. I can do that. My first derivative would just be this 6x squared plus 14x minus 4. To get our second derivative, we would get 12x plus 14. Now that's our answer. But let's have a little bit of fun. Let's say we wanted to take the third derivative. Well, that's just going to give me 12, of course. We can go further. We can take the fourth derivative. Now, once we get past the third derivative, we normally don't like to use primes, so we'll use the number 4 as a superscript there. So the fourth derivative of x is just going to become 0. This has a very special name for it. Once the derivative goes away, we get what's called the derivative annihilator. And that is actually what it is called. It has been annihilated. So I want to go off script a little bit, and I want to talk about the derivative annihilator itself for us. The derivative annihilator only occurs if we have a polynomial function or power function where n is a whole number. Now, if you forget what a whole number is, that's numbers like 0, 1, 2, and so forth. Nothing negative and no fractions or decimals. So we can take a look. If I know it's only whole numbers, I can find out when the derivative annihilator will occur. If my power was 3, it took 4 derivatives to become 0. So that gives me something. So the derivative annihilator is the n plus 1th derivative. So if I had x to the 100, so an example, if x to the 100, well, we're saying that the 101th derivative is going to become 0. So that's one little tidbit. But it also tells us something else. What would the nth derivative be? What would our nth derivative be? Well, that's another interesting little tidbit we can kind of talk about here. What if I want to find the nth derivative of a polynomial? Well, if we think about it, let's just take a look at something like x to the 5th. If I have x to the 5th, my first derivative is 5x to the 4th, 20x cubed for my second, 60x squared for my third, 120x for my fourth, and 120 for my fifth. So if n is 5, that's my fifth derivative is 120. Well, this might look familiar to you. What's the relationship between 5 and 120? Now, if you forgot that, that's okay. So let's look at this another way to do it. My first one, of course, would be 5x to the 4th. Bringing down the 4, I now get 5 times 4 times x cubed. Bring down that 3, 5 times 4 times 3x squared. And some of you might have figured this out. This is a factorial. So what that tells me is that the nth derivative would just be n factorial. Whatever the power is, factorial. And that's our nth derivative for this. Kind of interesting for us. A little bit of tidbit there. All right, let's have a little bit more fun. Let's let y equal the cosine of x. This is just a new notation. This is our Leibniz notation. But again, all it wants is a second derivative. So I'm going to take the first derivative. We're going to use Leibniz's notation, dy dx. And the first derivative, of course, is negative sine of x. I want to take the second derivative. Now, the 2's are located in very special places for us on purpose. So when I'm looking for the second derivative with respect to y, with respect to x. We put the 2 on the x because, remember, we're taking the derivative with respect to our variable x. And we're doing it for a second time. That's why I put the 2 there. The second derivative would be negative cosine of x. And, of course, that's our answer. But let's have some fun. Let's find the third derivative. This becomes negative of a negative sign, which becomes just sine of x. And let's do one more. Let's go and do our fourth derivative. The fourth derivative, well, the derivative of sine is just cosine of x. So if you notice, this is not going to have a derivative annihilator. As a matter of fact, you probably realized all we did was start over. We are just repeating ourselves now. So I can use that. What if I now want to find the 31st derivative? Well, if it repeats every 4, I can just take that, I can find my remainder. The closest 4 gets to 31 is 28. So if I divide that by 4, it goes to 77 times, gives me 28. My remainder is 3. So I have 3 left over. Well, what that's telling me is that this is going to be the same as our third derivative. So this is the same as our third derivative, which is just sine of x. So now I can do other things. Well, what's going to be the derivative of the 101st derivative? What's the derivative of the 122nd derivative? And we can have a little bit of fun with that. You're just looking for that remainder. Like if I wanted the derivative of the 122nd derivative, well, I know 4 will go into 120. That's going to leave me with a remainder of 2. My second derivative, negative cosine of x. There's my derivative right there. So this is number 127 from your homework for tonight, just an application of it. And this is what we call a differential equation. Real simple, a differential equation is any equation with a derivative. So if y is equal to 2 sine x plus 3, we want to show that the second derivative plus the function is 3. So this tells me I need the second derivative. So the first derivative is easy. 2 cosine of x. My second derivative, negative 2 sine of x. All I'm going to do now is I'm just going to plug in y double prime, second derivative, plus y equals 3. My second derivative, we just said, is negative 2 sine of x, plus the original y, that was this, 2 sine x, plus 3. I want to know if that's equal to 3. This is so easy. Look, those sine x's cancel, and we're left with 3 equals 3. That is it. QED. Old Latin for oblique. That's all, folks. All right, well, that's the end for part 1. Come to part 2, we're going to take a look at what we call the product rule. I look forward to seeing you then.